Hi, my name is Neil Shah. I'm a PhD student at Tufts University, and I'm answering this question today through Wyzant. So the question I'm looking at here is a precalculus question. It says we have some function x plus 3 all over x minus 1, and we want to find the inverse, right? So the way I like to approach this is, so we kind of have this idea, right, that we can define a quantity y and say that we have y equal to f of x. And this, of course, is equal to x plus 3 over x minus 1. Now what you can do is this the same thing, but do it for the inverse. We can say z, a different variable, equals f inverse of x. Now the property of functions and their inverses, right, is that if you have the function acted on its own inverse, you get x, right? The function takes x to a different number, and the inverse brings it right back. So you arrive right back at x, right? And of course, you can also write this in the other order. So this is kind of a property of functions and their inverses. So we can actually take this and this, right, and kind of use them both, right? We can say f of z equals x. And we know what f of x is, right? We know that f of x is this quantity right here. So f of z is going to be the same thing, but just z's instead of x's. So we're going to do z plus 3 over z minus 1. And what we're going to do is we're going to solve for z, right? So we're going to do, what we'll do is we'll multiply both sides of this equation by z minus 1. Z minus 1. And then what I'll do is just expand this. So I have xz minus x. And this all equals z plus 3. And now what I can do is combine z's and things that are not z's, right? So this is a coefficient times z, and then I'll subtract z from both sides. So I'll do minus z minus z. And also from both sides, what I'll do is do plus x plus x. So now z's here will cancel, and the x's here will cancel. Yes, we'll get xz minus z, and then we'll get x plus 3. Now what we'll do is we'll pull out a z on this side. So we'll get z times x minus 1 equals x plus 3. And then finally we get z, which remember equals the inverse of x, which is the answer we're looking for, is x plus 3 over x minus 1. There's the answer. So surprisingly enough, you notice that this is actually the same thing as f of x. This isn't normally true, right? This is actually a very special function for which the f of x actually equals the inverse of x. And we can actually quickly show this, right? We can see that if we do x plus 3 over x minus 1 plus 3. So what I'm doing is I'm basically replacing everywhere I see x in the original function with the function itself. So x plus 3 over x minus 1 minus 1. This is going to be x plus 3 over x minus 1 plus, we're still going to have 3 can be represented as 3 times 1, right? What we can do is we can define 1 equals x minus 1 over x minus 1, because anything over itself is 1. So get 3x minus 3. This is x plus 3 over x minus 1 minus x minus 1 over x minus 1. Well, what we'll get here is we'll get 4x over x minus 1 divided by 4 over x minus 1. And this is going to be x. So we get that f of f inverse of x, and in this case is f of x equals x. Perfect.